Where did everything come from? Has the universe always been here? Is there a creator of the cosmos, or is the cosmos all that exists? Far from being the inquiries of philosophers and scientists only, these are common worldview questions shared by all mankind. In the search for answers, a variety of cosmological arguments have been offered to explain why there is something rather than nothing. The cosmological argument assumes that something exists and argues from the existence of that thing to the existence of a first cause or a sufficient reason for the cosmos. In the search for a sufficient reason or explanation for the existence of the universe, there are three potential candidates to consider. The first is that the universe caused itself and is therefore its own explanation. The second possibility is that the existence of the universe is just a brute fact requiring no explanation. This may be because the universe exists eternally or necessarily. The third is that something other than the universe is responsible for bringing it into existence. Is it possible that the universe came into being from nothing, ex nihilo, without any external cause? When met with this question, sometimes people are tempted to think of a cosmic vacuum in which energy, strings, and other entities exist in fluctuation. Nothing, however, is not synonymous with a cosmic vacuum. Matter, energy, and even space itself, even if truly empty, are all something. Nothing, as Aristotle put it, is what rocks dream about. From nothing comes nothing, and it's impossible to contend that nothing could produce anything. Nothing producing anything has never once been observed, and if it could, why wouldn't we see this happen more often? As it is, something coming from nothing is less of a scientific idea and more of a metaphysical dream akin to magic. It is reasonable and intuitive that anything that begins to exist has a cause for its existence. But what if the universe didn't begin to exist because it has always existed? In a debate on January 28, 1948, hosted on the BBC radio station, atheist philosopher Bertrand Russell claimed that the universe is just there, and that's all. Is it possible that the universe has always existed and doesn't need an explanation for its existence? The first thing to consider when investigating this possibility is the nature of time. For the universe to be past eternal, an infinite amount of time would have to be allotted to have already passed. Is this possible? In 1924, the German mathematician David Hilbert presented a lecture in which he engaged in a thought experiment known as Hilbert's Hotel. The purpose of the experiment was to identify what problems might arise if actual infinities existed in the real world. He begins by asking us to imagine a hotel with a countably infinite amount of rooms, occupied by an infinite number of guests. The sign outside reads, "No vacancy." Late at night, a traveler with nowhere else to go enters the hotel to seek refuge from a storm. The hotel manager, who happens to be in the lobby, begins to explain that all the rooms are full, but then he has an idea. He decides to move the guests in room 1 to room 2, and the guests in room 2 to room 3, and so on until all the guests have moved to the next room after theirs. This frees up the first room for the traveler, and he is now able to stay the night. The next night, a large bus full of an infinite number of passengers arrives to stay at the hotel. But again, the hotel is already full. This time the manager decides to move the guest in room 1 to room 2, the guest in room 2 to room 4, and the guest in room 3 to room 6, and so on until all the guests are occupying only the even-numbered rooms, freeing up the infinite number of odd-numbered rooms for the infinite busload of new guests. Afterwards, the manager changes the sign outside to read, "No vacancy, all welcome. Hilbert's Hotel shows the absurdities that would result if actual infinities existed in the real world. This type of argument is known as argument ad absurdum, argument from absurdity. By showing that the conclusion of the argument is absurd or impossible, this invalidates one or more of the premises, like the premise, actual infinities exist in the real world. Another philosophical problem with actual infinities regards counting. Some will contend that if we can count a finite portion of infinity, then we can count the whole. This commits the fallacy of composition, confusing a property of a part with the property of the whole. Parts of infinity can be counted, but the whole of infinity cannot. To understand why, think of a line of dominoes, infinite in number. They are all black except for one red domino. The red domino represents the present moment. The black domino after it represents the moment right after, and the black domino before it represents the moment just before it. In order for the present moment to happen, the red domino must fall, but in order for it to fall, the black domino before it must fall first. In order for that black domino to fall, the black domino before it must fall before it, and so on forever and ever. As you stack black dominoes before it one at a time, you come to realize that you will never reach the end of stacking, because there are an infinite number of dominoes to stack. Because you can never get to the beginning to make a domino fall, you will never reach toppling the red domino. If a series of events in the past were infinite in number, it would take forever to reach this present moment, and therefore never actually happen. But the present moment does exist. We are currently experiencing it, and therefore the past cannot be an infinite duration of time. While philosophical arguments have long argued against an eternal universe, the Kalam Cosmological argument has recently undergone tremendous revision due to the robust amount of scientific discoveries in the areas of cosmology and physics. In 1915, Albert Einstein published his general theory of relativity, which suggested the universe may be expanding. Using his theory, he created a mathematical model of the universe, but he discovered something disturbing. His model from general relativity clearly implied the universe has a tendency to expand and perhaps contract. Einstein was rather shocked at this result because he, along with everyone else, thought the universe was unchanging in size. Though Einstein would initially try to avoid this conclusion, Alexander Friedmann did not, and published the Friedmann equations in 1922. 5 years later, George Lemaitre suggested estimated values for the rate of expansion. These values were corrected, and the expansion of the universe was confirmed by Edwin Hubble in Hubble's law, using the red shift of objects in deep space. See Doppler shift. The idea that the further away a galaxy is, the faster it is moving away, was as stunning as was the result that the vast majority of galaxies were red-shifted. These were clear indications that the universe is expanding, that it is dynamic rather than static. The expansion of the universe leads backward to an initial cosmological singularity, or starting point. At this singularity, space and time came into existence. Literally nothing existed before the singularity. So, if the universe originated at such a singularity, we would truly have creation ex nihilo. A past eternal universe cannot be expanding. This is known as the Standard Model, or more commonly referred to as the Big Bang. The Standard Model, however, was not the only theory on the market. Competing steady-state models, theories in which the universe exists eternally, were being proposed by scientists like Hermann Bondi, Thomas Gould, and Fred Hoyle. These steady-state models were shortly undermined in 1965 when Arno Penzias and Robert Wilson accidentally discovered the cooled-down background radiation left over from the beginning of the universe. The cosmic background radiation was later confirmed and mapped by NASA in the early 1990s with the Cosmic Background Explorer, COBE. And the relative abundance of light elements, another prediction of the Standard Model, was confirmed by the Wilkinson Microwave Anisotropy Probe, WMAP, launched in 2001. 1. Between these measurements and the cosmic microwave background radiation measurements, virtually all astronomers and cosmologists dropped the steady-state model as unsupported by the observations. Even given the data, non-standard models continue to persist in attempts to avoid an absolute beginning. Models like closed time-like loops, eternal inflation, quantum gravity, oscillation, and others could never match the power of the standard model. It can be confidently said that no cosmogonic model has been as repeatedly verified in its predictions and as corroborated by attempts at its falsification, or as concordant with empirical discoveries and as philosophically coherent as the standard Big Bang model. One of the results of an expanding universe is the effects of entropy, the second law of thermodynamics. Entropy, simply put, is the scientific principle that energy degrades over time as the universe continues to expand. Once all the energy in the universe has been spread out and lost, the universe will reach a state of equilibrium, otherwise known as the heat death of the universe. The clear implication of entropy is a universe with a definite beginning. Imagine finding a mug of coffee with steam rising from it. It's reasonable to conclude that this cup of coffee was brewed recently, because given enough time, it will cool and cease to steam. If the universe had existed forever, why hasn't it run out of energy by now, since it has had an infinite amount of time to expand? With the proof now in place, cosmologists can no longer hide behind the possibility of a past eternal universe. There is no escape. They have to face the problem of a cosmic beginning. If the universe has inherent attributes, properties, or characteristics, then it follows that its cause must transcend those qualities in some way. Because the universe is comprised of space, time, and matter, the cause must be spaceless, timeless, and immaterial. This cause must also possess an unfathomable amount of power to generate the universe. There are only two possible candidates that can be described as spaceless, timeless, and immaterial. 1, abstract objects, like numbers, or 2, an unembodied mind, or consciousness. The problem with the first option is that abstract objects lack what philosophers call agency. Numbers cannot choose or decide. They are not prescriptive, but rather descriptive. They only describe what is, but cannot alter reality as it is. The number 5, for example, has never caused anything, nor can it. The second, however, is a viable option. An unembodied mind would meet the criteria described and possess agency. If what caused the universe is more like a mind than anything else, then it would be personal, because it chose to create the universe. The arguments of philosophy and the evidence of science converge to a single verdict. The cause of the universe is a spaceless, timeless, immaterial, incredibly powerful, personal mind. This mind is God. For the scientist who has lived by his faith in the power of reason, the story ends like a bad dream. He has scaled the mountains of ignorance. He is about to conquer the highest peak. As he pulls himself over the final rock, he is greeted by a band of theologians who have been sitting there for centuries.